how to count factors of a given number. Let's do this with an example. Let's try to count the factors of 24. Now 24 can be written as 1 times 24. So 1 and 24 are factors. Let's make a list of factors here. List of factors. And let us write 1 and 24 here. Okay. The next number that we'll do is 2. And 2 times 12 is also 24. So 2 and 12 are factors. 2 and 12. Similarly, 3 times 8 is 24. So 3 and 8 can go in the list. Let's do 4 now. So 4 times 6 is 24. We can write 4 here and 6 here. The next number is 5, and we know that 24 is not divisible by 5. So 5 is not in the list. And then we have 6. But 6 is already in the list. In fact, we're done with all the numbers that are greater than 6. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. A total of 8 factors. Well, this method works, but what we're trying to do here is to come up with a method to count the number of factors without the need to actually write them down. So how do we do that? First, we need to write the number 24 in its prime factorization form. So 24 is 8 times 3, and you can write 8 as 2 to the third power, which makes 24 equal to 2 to the third power times 3. Now we need to make a first important observation. We note that 24 is made up of 2's and 3's. There's no other prime number involved, as we can see from its prime factorization. What we also note is that every factor of 24 is also made up of just the 2's and 3's. Take for example 6, which is 2 times 3, or 12, which is 4 times 3, but 4 is not prime, so we can rewrite it as 2 square. So 12 equals 2 squared times 3. Again, 2's and 3's. What about 8? Now 8 can be written as 2 cubed. There's no 3 here, but that's fine, as long as we're not using any prime number that's not in 24. The point that we're trying to make here is the things that make up 24 are the same things that make up its factors, or the factors are made up of the same primes as the number. The factors are made up of the same primes as the number. The second important observation is that the factors cannot have more 2's than 24 or more 3's than 24. We're fine with no 2's or no 3's, but the factors of 24 cannot have more of something than 24 itself. Let me show you what I mean with this table. I'll place the powers of 2 here, 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. And the powers of 3 here, 3 to the power 0 and 3 to the power 1. And now let's multiply these different powers of 2 with the different powers of 3. So 2 to the power 0 is 1, as anything to the power of 0 is 1, and so is 3 to the power of 0. So 1 times 1 is 1. In fact, let me write these powers as numbers so it will be easy for us to multiply. We have 1, 2, 4, and 8 here, and 1 and 3 here. So this becomes 1 times 3, which is 3. This is 2 times 1, which is 2. This is 4 times 1, which is 4. This is 8 times 1, which is 8. 2 times 3 is 6. 4 times 3 is 12. And finally, 8 times 3 is 24. And these are all the factors of 24. And none of them have more than 3 2's or more than 1 3's. But let's delete these cells from the table, because we don't really need these factors. All we need is the total number of them. Let's suppose that we don't have any of the factors of 24 and we're trying to make one from scratch. So if we have to make a factor of 24, we'll need powers of 2 multiplied by powers of 3. For the power of 2, we have 4 options. It could be 0 or 1 or 2 or 3. So the number of ways that we can write a power here is 4. So 4 ways. Now for the power of 3, we have 2 options, that is 0 and 1. So the number of ways that we can write a power of 3 here is 2. So 2 ways. So the total number of ways that we can make a factor of 24 is 4 times 2, which is 8 ways. And now we know that we can get to this value of 8 without actually writing down the individual factors. All we need to know is the prime factorization of 24. Alright, now that we know how to count the number of factors, let's go a step further. Let's try to find out the number of even factors of 24. So, if we have to make a factor of 24, we'll start with the powers of 2 multiplied with the powers of 3. Now, since we want an even factor, we need at least one power of 2 in the factor that we are making. Since all even numbers are divisible by 2, we cannot afford to have no 2's in our factor. So the options available for the power of 2 are 1, 2, and 3. So 3 ways. For 3, we still have 2 ways. And so we have 3 times 2 equals 6 factors of 24 that are even. So we have 6 factors of 24 that are even. Let's see how many odd factors we can make. In this case, we'll have no 2's because even a single 2 can make this number even. So the power of 2 has only one option, 0. There's just one way to fill the power of 2. Again, the power of 3 can have 2 ways. And 1 times 2 is 2. So there are 2 odd factors of 24, which are 1 and 3. And why 2? Let's see if we can find the number of factors of 24 that are divisible by 3. For them to be divisible by 3, the power of 3 has only one option, that is to be 1. For 2, we have 4 options, 0, 1, 2, and 3. So 4 times 1 is 4. So we have 4 factors of 24 that are multiples of 3. And we can see that this logic will work for any number as long as we can find its prime factorization. All we need to do is to find out the prime numbers involved, and the powers that they can have. Let's try one more question. How many factors of 240 are even but not divisible by 4? How many factors of 240 are even but not divisible by 4? You can pause the video to give this problem a try. Okay, the first thing that we need is the prime factorization of 240. So 240 is 2 times 120, which is 2 times 60, which is 2 times 30, which is 2 times 15, which is 3 times 5. So 240 is 2 to the 4th power times 3 times 5. So the numbers that we are looking for are factors of 240. This means that the primes that we are allowed to use are 2, 3, and 5. The next thing is to find out what are the options available for the powers of 2, 3, and 5. So if the factor is even, it cannot have 0 2's. It should have at least one as a power of 2. But if it has more than 1 as a power of 2, then the factor will not only be divisible by 2, but 4 as well. So it should have at most 1 as a power of 2. At least 1, at most 1. So the only option left for the power of 2 is 1. So factor equals 2, 3, and 5. The only available power of 2 is 1. The number of ways that we can fill in the power of 2 will be 1. 3 has 2 options, 0 or 1. So 2 ways. 5 has 2 options as well, 0 or 1. So 2 ways. So the total number of required factors are 1 times 2 times 2, which equals 4. So there are 4 factors of 240 that are divisible by 2 but not by 4. And I like this approach as it gets to the answer without having the need to find irrelevant details about it. We didn't need to find the factors, we were only asked to find the number of factors. And that's exactly what we did.